Alright, the position function of a moving particle is given by s of t is equal to the cube root of t to the power 5 minus 750 t squared, where s is in meters and t is in seconds. Determine the velocity of the particle at 5 seconds. So if we're looking at the velocity function v of t is the first derivative of the position function s of t. So if we're finding the derivative of this, we can kind of just identify the fact that this basically does look like a composite function, and we have to utilize chain rule. So if we're utilizing chain rule, we're basically going to be looking at, so s prime of t here is equal to, I'm going to be using first the power rule, but before I actually do that, I'm going to just kind of clean up s of t and write it as an exponent. So you can rewrite this as t to the power 5 minus 750 t squared to the power of 1/3. Okay, so s prime of t here is basically equal to the derivative of the outside, right? So recall that if f of x is equal to g of h of x, right? This is basically the template where you would use chain rule when you have a composite function. F prime of x is equal to g prime of h of x. And then you do the derivative at the inside, so h prime of x. Okay, so I'm just using Lagrange's notation. Then you utilize the same thing here. So you do the derivative of the outside, so you get 1/3 t to the power 5 minus 750 t squared. And then you're going to subtract by 1, so you get negative 2/3. And then I'm going to do the derivative of the inside, so d with respect to the derivative with respect to dt, the rate of change of time, t to the power 5 minus 750 t squared. Okay, and this is going to give us s prime of t is equal to 1/3 t to the power 5 minus 750 t squared to the power negative 2/3 times 5t to the power 4 minus 150 t. Okay. Now we want to figure out the velocity of the particle at 5 seconds. So we're basically figuring out, so this is your velocity function, right? So you can just kind of write here that this is your velocity function. And you want to figure out the velocity at 5 seconds. So if you plug this in, you get 1/3 5 to the power 5 minus 750 to the power 5, 750 times 5 squared to the power negative 2/3 times 5 times 5 to the power 4 minus 150 times 5. Okay, so if you want to crunch this out, right, so this is 1/3, this is 25 minus 750 times 25, which is 18,750 to the power negative 2/3 times, in this case you should see 5 to the power 5. So the numbers are quite extensive. Minus 150 times 5. So this is 2,375. And if you simplify this, 25 minus 18,750, negative 18,725. So this is going to give you cube root negative 18,725 squared times 2,375. Okay, so if we crunch this out, I'm just going to put all this in a calculator. I'm going to give you guys a final answer. So I got something that looks like 2,325 over 2,115.448. And if I divide this guy out, I got 1.099. Okay, so let's just round this guy off to 1.1. Okay, so the velocity of the particle at 5 seconds approximately is 1.1 meter per second. Okay, so yeah, the numbers are a little significant in that scenario. But that's basically how you would tackle the problem.